Learning made easy. Metallurgy for everybody. When we glance at the periodic table, we see pure elements. Many times for the required application, pure metal or element are not suitable. Their properties are required to be modified. Properties of alloys can be modified with knowledge of phase diagrams. For this, we have to understand some concepts such as mixture, compound and solid solution. When we walk around the seashore, we observe sand and water which are getting mixed and separated every now and then. It is a mixture of sand and water. So the properties of mixture are no chemical reaction when mixed or separated. Chemical and physical properties do not change before mixing and after mixing. Ratio of components may vary. Other example is perlite. Perlite is a mixture of ferrite and cementite observed in steel. Microstructure of perlite, which is a mixture of ferrite and cementite as observed under the microscope, is similar to zebra stripes. Now let's have a look at what is compound. Water is compound of hydrogen and oxygen. Hydrogen atoms combine with oxygen atoms to form water. Chemical reaction occurs during transformation. Chemical and physical properties change after transformation. Properties of oxygen and hydrogen are totally different than water. Ratios of components are fixed. Two atoms of hydrogen react with one atom of oxygen to form water, H2O. Other example is a cementite. Cementite is a compound of iron and carbon. Cementite can be observed in steel, where 12 atoms of iron combine with 4 atoms of carbon to form cementite. This is how the cementite microstructures look like of 0.8% carbon steel. Let us consider example of nickel and copper for solid solution. Radius of nickel atoms is near about the same as that of copper atoms. When nickel and copper are heated to the liquid phase, in that case, both elements will get dissolved into each other, forming solid solution when cooled down from liquid phase to solid phase. Here we can see a solid solution of 25% nickel in copper, and also we can see 50% nickel and 50% copper solid solution. Points to be noted are chemical reaction do not occur. Alloying element dissolve in parent metal to form solid solution. Chemical and physical properties do change after formation of solid solution. Melting point of brass is lower than copper, and brass is also having a better malleability than the zinc and copper. Steel is having different properties than iron and carbon. When certain atoms in the crystal lattice are completely substituted by different element atoms, we call it as a substitutional defect. Example, copper and nickel atoms substitute each other, nickel atom replacing copper atoms and form substitutional solid solution. As in the case of steel, it can be interstitial defect when carbon is occupying space between the ion atoms. Solid solution is known as interstitial solid solution. Now let's consider the example of iron and carbon. Radius of the iron atoms is around twice the radius of carbon atoms. Both iron and carbon can be heated to liquid phase. Carbon atoms dissolve into the iron atoms. Outcome is alloy known as steel. Example of solid solutions such as ferrite phase and austenite phase can be seen in this microstructure of steel. Ferrite is a solid solution of iron and carbon. Crystal structure is BCC. While austenite is also solid solution of iron and carbon, but crystal structure is FCC. Generally, a material which is composed of two or more chemical elements is known as alloy, where metallic atoms predominant in composition. The element present in large proportion is base element and other elements are called alloying elements. Alloy is generally solid solution where mixture or compound can also be observed in matrix. Example is 0.8% carbon steel, where we can see ferrite, which is a solid solution, pearlite, which is a mixture of ferrite and cementite. Cementite is a compound of iron and carbon. Phase is physically homogeneous state of matter with uniform and distinct atomic arrangement. Phases of H2O are water, steam and ice. Phases observed in steel are ferrite, pearlite and cementite and so on. As the properties of alloy depend upon the type of phase present, understanding phase diagrams is very important. Phase diagrams or equilibrium diagram gives information about various phases with respect to temperature and composition of alloy. Phase diagrams are prepared on the basis of slow heating or cooling so that atoms freely move around to maintain equilibrium. Phase diagrams can be unary, that is single component, example is H2O. Binary, two components, example is copper and nickel. Ternary, three components. Quaternary, four components. Now let's have a look at H2O phase diagram. Pressure is plotted on vertical axis while temperature is plotted on horizontal axis. We all know that at room temperature H2O is in liquid phase, that is water, while when heated at 1 atmosphere pressure at 100 degrees Celsius its phase changes to gaseous state, that is steam, while when cooled down below 0 degrees Celsius its phase changes and is called as ice. If we plot the diagram for different pressures and temperature, it will look like this. When substance is heated, it transforms from solid phase to liquid phase. It is known as melting. Heat is being absorbed by substance until entire substance transforms to liquid phase and temperature remains constant till complete transformation. Then temperature increases. When substance is cooled, the temperature drops up to the crystallization temperature. The temperature remains constant till complete substance solidifies. Then temperature further decreases. Let's consider the example of copper and nickel. Nickel and copper are completely soluble in each other. When copper is heated to liquid phase, then on cooling, temperature of metal drops up to 1085 degrees Celsius. Temperature remains constant till entire metal is solidified and again temperature drops and metal cools. Here we have liquid phase above crystallization temperature and solid phase below. When nickel is heated to liquid phase, then on cooling, temperature of metal drops up to 1455 degrees Celsius. Temperature remains constant till complete metal is solidified. Again, temperature drops and metal cools. Here we have liquid phase above crystallization temperature and solid phase below. Cooling curves for pure metals look similar while melting points are different. When copper along with 25% nickel are heated to liquid phase and cooling curve plotted till solidification, we will have a liquid phase, liquid plus solid phase and solid phase. We are having two breakpoints, one when solidification starts and other when solidification is completed. In case of 50% nickel and 50% copper, cooling curves will be similar but temperatures will be higher. Also for the 75% nickel and 25% copper, cooling curve will be similar with further higher temperature. When line is drawn joining these boundary points of cooling curves, we get a simple phase diagram. Liquid line separating liquid phase and liquid plus solid phase is known as liquidus, while solidus is a line separating solid phase and solid plus liquid phase. There are three variables: temperature, pressure and composition. As practically all processing is carried out at normal atmospheric pressure 1 bar, so phase diagrams are plotted with temperature on vertical axis and composition on horizontal axis. Phase diagrams provide complete information about various phases at different percentage of elements with respect to temperature. Here we see a phase diagram of copper and nickel alloy. Copper and nickel atoms are near about same size. Copper and nickel are completely soluble into each other. They form substitutional solid solution. Crystal structures of copper and nickel are FCC. Topics discussed are basic concepts about mixture, compound, solid solution, alloy, substitutional solid solution, interstitial solid solution, phase, phase diagram, phase diagram of H2O, phase diagram of copper and nickel. Topics to be discussed in next videos are phase diagram with incomplete solubility and ion carbon diagram. Thanks for watching. Like, share and subscribe. Press bell button for notifications.